thought it was worth going through this again. So this question, total surface area of a solid hemisphere, that's important, is equal to the curved surface area of a cylinder. Radius of the hemisphere is r, radius of the cylinder is twice the radius of the hemisphere. Right, okay, so start with that. Let's start with the diagram. So a hemisphere is half of a sphere, and they've told us it's a solid hemisphere, so that means it's got a top. Okay, so first thing, the surface area of a sphere, you'll be given in the exam, but that is 4 pi r squared. And then we have a cylinder. Okay, but we're only interested in the curved surface, which is the middle section. Now, this basically has to wrap around the top and bottom, which are circles. So this is actually a rectangle that's wrapped around the circle. And that means that the width has to be the same as the circumference of the circle. And we know that that is pi d, or 2 pi r. But in this case, the r is actually 2r, because the radius, we're told, is twice the radius of the hemisphere. And then the height is simply height. Okay, so what we're going to do is somehow relate this to volume. Okay, so at the moment we're only talking about the surface area, which is the first part of this question. So what I'm going to do is write this as a single equation, and I'm going to try and work out what h is, so that I can substitute it into the volume equations. Right, so we've been told that 4 pi r squared, and we've got to add the top of that circle, which is pi r squared. That's our solid part, the lid, if you want, to our hemisphere. And we're going to halve that because it's a hemisphere, not a sphere. So I've got 4 pi r squared over 2 plus pi r squared. Well, we know that we can divide through and make that 2 pi r squared. So I've got 2 pi r squared plus pi r squared, and that is equal to the curved surface area, which is our middle section, which is 2 pi times 2r, so that's 4 pi r times h. Okay, well, let's look. So on the left-hand side, we've got some like terms, because we've got our pi r squareds. So we've got 2 pi r squared plus pi r squared. Well, that's just 3 pi r squared. And that is equal to 4 pi r times h. Okay, well, I want h to be the subject, so I need h on its own. So I'm going to divide by 4 pi r. So I've got 3 pi r squared divided by 4 pi r. Right, now let's simplify that. Well, I've got 3 divided by 4, 3/4. I've got pi divided by pi, which is just 1. And I've got r squared divided by r, which is r. Right, so now I can say what h is. H is equal to 3/4 of r. Right, now we can move on to the second part of the question, which is how we find that ratio. So now we want to think about volume. Okay, so volume of a hemisphere, well, volume of a sphere is 4/3 pi r cubed, and we're going to have that in a ratio to the volume of our cylinder, which is a prism. So that's basically the cross section times the height. So that is going to be pi r squared times h. Now again, remember our cylinder had twice the radius, so that's 2r. So that means that I've got pi times 4r squared times h. And at this point, I'm going to substitute in my definition of h. So that's pi times 4r squared times 3/4 of r. Right, so now let's expand all that out. That means that I've got 3/4 of pi times 4r cubed. And you can see that I'm multiplying by 4 and I'm dividing by 4. So I've just got 3 pi r cubed. And that's a ratio to 4/3 pi r cubed. Oh, and that's our sphere, so that's half of that, so that's half of that, and that's half of that. So finally, for my hemisphere, I've got 2/3 pi r cubed to 3 pi r cubed. Well, you can see that I can cancel out all of this. So I've got 2/3 to 3. So if I want it 1 to m, then what do I do? Well, okay, if I multiply this by 3, I'll have 2 to 9, and then I need to divide this by 2. So I divide 9 by 2, and then that means m equals 9 over 2. And that's our final answer.